sklearn Gaussian process kernel's constant kernel. Description: the constant kernel represents a constant function in the Gaussian process GP model. It is a simple kernel that assumes the target function is approximately constant, leading to a flat prior over the function space. This kernel is often used in combination with other kernels to account for global bias or scaling. In the data inputs, XA2D array representing the input data points. Each row corresponds to a data point, and each column corresponds to a feature. YA1D array representing the target values corresponding to the input data points. Outputs, KA2D array representing the kernel matrix. The element at position I, J in the matrix represents the similarity between the ITH and JTH data points. Steps: the constant kernel takes the input data X and calculates the similarity between each pair of data points. The kernel matrix K is then calculated using the formula key J constant value matrix R squared measures the proportion of the variance in the target values that is explained by K model. Mean squared error MSE measures the average squared difference between the predicted values and the actual values. Visualization plots. Scatter plot of the input data points colored by their target values. Heat map of the kernel matrix showing the similarity between data points. Fine-tune parameters. Constant value, a scalar value representing the constant value of the kernel. This parameter determines the overall scale of the kernel function. Uncertainty methods. Bayesian confidence intervals provides a measure of uncertainty in the predicted values based on the posterior distribution of the GP model. Predictive variance measures the variance of the predicted values at each input point. Challenges and fixes. Challenge 1: overfitting. If the constant value is too high, the model may overfit the data, leading to poor generalization performance. Sample use case that resulted in challenge 1: using a high constant value for a dataset with a strong underlying trend. Fixes to challenge 1: reduce the constant value or combine the constant kernel with other kernels to model the trend. Challenge 2: underfitting. If the constant value is too low, the model may underfit the data, failing to capture the global bias in the target function. Sample use case that resulted in challenge 2: using a low constant value for a dataset with a strong global bias. Fixes to challenge 2: increase the constant value or combine the constant kernel with other kernels to account for the global bias.